All right, so this is the periodic table. So after we got through with the electrons, we went right into looking at the periodic table. So first of all, you need to know your families. So families, remember, are the vertical. This is a family. In fact, it's the alkali metals, right? So that's the alkali metals, meaning they have one valence electron. Here's the thing about families. Families have the same number of valence electrons. If I look at this, the rows like this is a period, okay? And your periods have the same number of energy levels. So everything in this row is going to have at least four. It's going to have 4 energy levels. Now, things you need to know. Right here, if we keep going down our little staircase, this would be the metalloids. These are the ones that separate. So everything on this side is a metal. We called it cations because it likes to lose its electrons, becoming positive. Everything on this side of the metalloids are nonmetals, and they tend to be anions, and they gain electrons, making them negatively charged. So when you're looking at your periodic table, think about some of the characteristics that metals have, okay? Metals have, they're ductile, they're malleable, they're shiny. So everything on this side is my metals. So the majority of the periodic table are my metals. You need to know your families, like we quizzed on earlier. These are your noble gases. What does it mean by noble gas? It means that they don't react. They have a full outer shell. Remember, all atoms are trying to get to a full outer shell. That's why they're gaining and losing electrons. These metalloids, that the staircase, they have properties of both metal and nonmetals. That's why they're kind of the in-between. So, you know, what you're going to make sure you need to do is, like, if I give you, you know, something like this and this, what could you say they have in common? Well, they have the same number of valence, meaning they're going to have 6 valence electrons, and they have an oxidation number of -2. All right. How would you compare this one and this one? Well, they're in the same period, so they're going to have the same number of energy levels. The next thing, or the last thing that we did with the periodic table, is we looked at trends. And so I'm going to erase all this. Okay. And we're going to look at some of the trends that we learned about. So trends means, you know, what do we see taking on or happening in this periodic table? First of all, if you notice, the periodic table is arranged by atomic number. It used to be arranged by the atomic mass. That's how Mendeleev arranged it, but now we do it by atomic number. So the first thing I want to talk about is atomic size. Atomic size is how big is it? Atomic size goes down the family and to the left. All right, so this right here is my biggest. So this is my atomic size. So you need to be able to put in order. Like, for example, if I've got calcium, silicon, cadmium, all right, rank in order of increasing atomic size. So first would be, this would be your first one, second one, third one. So calcium would be the biggest because it's further to the left and further down. All right, let's look at ionization energy. So ionization energy is the energy needed to pull off an electron. Ionization energy goes up and over. So helium, our noble gases, have the highest ionization energy. So if I wanted to look at a trend, as I go up a family and over to the right, my ionization energy increases. So put these in order. Sulfur, gallium, and tellurium. Okay. In terms of ionization energy, which is going to have the highest? Well, if I look, let's skip tellurium and let's do selenium. Okay. If I look, this is going to have the lowest, right? So it's going to go 1, 2, 3, because I'm further to the right and I'm further up. This is why this has the highest. Okay, the last one that I did in terms of trends is electronegativity. And electronegativity is how greedy an atom is for electrons. It follows the ionization energy pattern, but it stops at fluorine. No electronegativity for your noble gases, okay? They're already full, so they don't want to pull on any more electrons. So let's look at which has more electronegativity, magnesium or titanium. And it would be titanium because it's further to the right. All right, which has more electronegativity, chlorine or bromine? Chlorine, because it's further up. Okay, so that's what you're looking at in terms of trends. You need to be able to put these in order of atomic size, ionization energy, and electronegativity.